Grounding an above-ground pool without a metal structure requires alternative methods to ensure electrical safety. Here are some options and instructions. Firstly, consider using a grounding rod. Drive a copper-plated grounding rod into the ground at least 8 feet deep and at least 6 feet away from the pool. Connect the grounding rod to the electrical panel using an 8 AWG copper wire. Run the wire from the panel to the pool and connect it to the liner using a grounding clamp. Secondly, you might use a grounding plate. Install a grounding plate made of copper or galvanized steel in the ground, buried 24 inches deep and 6 feet away from the pool. The plate should be at least 12 inches by 12 inches. Run an 8 AWG copper wire from the grounding plate to the electrical panel and another 8 AWG wire from the grounding plate to the pool liner. Now let's talk about instructions for grounding via the liner. But first, a caution: before modifying the pool liner, ensure that the pool is fully drained. Locate a section of the pool liner where the seam is visible. Cut a small hole in the liner at the seam using a knife or hole punch. Insert a grounding clamp through the hole and fasten it to the metal reinforcement strip inside the liner. Tighten the clamp securely using a screwdriver. It is important to use only corrosion-resistant materials such as copper or galvanized steel for all grounding components. Consult your local building codes and electrical codes for specific requirements in your area. It is recommended to have a qualified electrician perform the grounding work for safety and compliance reasons. The purpose of grounding a swimming pool is to provide a low impedance path for fault current to return to the source, typically the electrical panel, in the event of an electrical fault. This helps to quickly trip the circuit breaker or ground fault circuit interrupter, also known as a GFCI, protecting people from electrical shock hazards. The National Electrical Code, also known as NEC, provides detailed requirements for grounding and bonding swimming pools to ensure electrical safety. Bonding refers to connecting all metallic parts of the pool and its surrounding structures to create an equipotential plane, minimizing voltage differences and reducing the risk of electric shock. Grounding, on the other hand, connects the bonding grid to the earth, providing a path for fault current. The NEC mandates specific requirements for grounding and bonding swimming pools to minimize the risk of electrical shock hazards. These requirements are outlined in Article 680.26 of the NEC, which covers equipotential bonding, and Article 680.21, which covers wiring methods. Some key aspects of the NEC requirements include the following. Firstly, equipotential bonding. All metal parts of the pool structure, including the reinforcing steel, metal fittings, and any metal within 5 feet of the pool, must be bonded together. This includes metal fences, ladders, diving boards, and other metallic structures. Secondly, bonding conductor size. The bonding conductor must be a solid copper conductor not smaller than 8 AWG. This conductor connects all the metallic parts to create an equipotential bonding grid. Thirdly, grounding electrode system. The pool's bonding grid must be connected to the electrical system's grounding electrode system. This typically involves connecting the bonding grid to the building's grounding electrode system, which may include grounding rods, metal water pipes, or concrete-encased electrodes. Fourthly, underwater lighting. Underwater lighting fixtures must be installed in accordance with NEC requirements, including proper grounding and bonding. The fixtures must be listed and labeled for underwater use and installed with the ground fault circuit interrupter protection. Fifthly, electrical equipment. All electrical equipment associated with the pool, such as pumps, filters, and heaters, must be properly grounded and bonded. These equipment should be installed by a qualified electrician in accordance with NEC requirements. Sixthly, GFCI protection. Ground fault circuit interrupter protection is required for receptacles and electrical equipment located within a certain distance of the pool. This helps to protect against electrical shock hazards by quickly interrupting the circuit when a ground fault is detected. When grounding an above-ground pool, you should consider the following. Firstly, grounding rod installation. Drive a copper or copper-clad steel grounding rod into the ground near the pool. The grounding rod should be at least 8 feet long and driven deep enough to make good contact with the earth. Secondly, conductor size. Use an 8 AWG or larger solid copper conductor to connect the pool's bonding grid to the grounding rod. This conductor should be installed in a direct and permanent manner without any splices or joints. Thirdly, bonding connections. Ensure that all metal parts of the pool structure, including the pool wall, metal supports, and any metal accessories, are properly bonded together. Use corrosion-resistant connectors and hardware to make the bonding connections. Fourthly, water bonding. In some cases, it may be necessary to bond the pool water to the bonding grid. This can be achieved by installing a listed water bonding fitting in the pool's circulation system. Fifthly, inspection. After completing the grounding and bonding work, have it inspected by a qualified electrical inspector to ensure compliance with NEC requirements. The grounding rod should be installed at a location that is accessible for inspection and maintenance. It should be driven into the ground until its top is below the surface, and the area around the grounding rod should be kept clear of debris and vegetation. Regular inspections of the grounding and bonding system can help identify any potential problems, such as loose connections or corrosion. Addressing these issues promptly can help maintain the effectiveness of the grounding system and minimize the risk of electrical shock hazards. It is essential to consult the latest edition of the National Electrical Code and local electrical codes for specific requirements and guidelines related to grounding and bonding swimming pools. Additionally, hiring a qualified electrician is recommended to ensure that the work is performed safely and in compliance with applicable codes and regulations. An equipotential bonding grid is a network of interconnected conductors that are installed around a swimming pool to create an area of equal electrical potential. The purpose of the equipotential bonding grid is to minimize voltage differences between metallic objects and conductive surfaces in and around the pool, reducing the risk of electric shock hazards. The equipotential bonding grid typically consists of a network of solid copper conductors that are buried underground or installed within the pool structure. These conductors are connected to all metal parts of the pool, including the reinforcing steel, metal fittings, and any metal within a certain distance of the pool, such as fences, ladders, and diving boards. The conductors are typically connected using corrosion-resistant connectors and hardware to ensure reliable electrical connections. The equipotential bonding grid is designed to equalize the electrical potential of all metal parts and conductive surfaces in the pool area. This means that if a fault occurs in the electrical system, the voltage on all these surfaces will rise and fall together, minimizing the voltage difference between them. This reduces the risk of electric shock if a person comes into contact with two different surfaces simultaneously. The equipotential bonding grid is connected to the electrical system's grounding electrode system, which provides a path for fault current to flow back to the source. This helps to quickly trip the circuit breaker or ground fault circuit interrupter, protecting people from electrical shock hazards. The installation of an equipotential bonding grid is typically required by electrical codes, such as the National Electrical Code, to ensure electrical safety in swimming pool areas. The codes specify the minimum size and type of conductors to be used, as well as the methods for connecting the conductors to the pool's metal parts and the grounding electrode system. The installation of an equipotential bonding grid should be performed by a qualified electrician who is familiar with the requirements of the electrical codes. The electrician will ensure that the bonding grid is properly installed and connected, and that all connections are secure and corrosion resistant. Regular inspections of the equipotential bonding grid can help identify any potential problems, such as loose connections or corrosion. Addressing these issues promptly can help maintain the effectiveness of the bonding grid and minimize the risk of electrical shock hazards. In addition to the equipotential bonding grid, other safety measures should be taken to protect against electrical shock hazards in swimming pool areas. These measures may include the installation of ground fault circuit interrupters, also known as GFCIs, on electrical circuits serving the pool, as well as the use of non-conductive materials for pool decks and fences. By combining an equipotential bonding grid with other safety measures, it is possible to create a safe and enjoyable swimming pool environment for all users. Remember that when cutting into the liner to ground, only do so after it is completely drained. Locate the seam of the liner and work at that point. Only after confirming the structure of the liner should a small hole be carefully cut into the liner to access any metal reinforcement strips inside, if any. It is best to seek professional advice as stated many times before. Also, when using a grounding clamp, make sure the clamp is suitable for direct burial and compatible with the metal of the liner reinforcement and the grounding conductor to prevent corrosion. The size of the grounding conductor, typically 8 AWG copper, should be sufficient to handle potential fault currents. When using a grounding plate, ensure it meets the minimum size requirement specified in the local codes and is buried at the correct depth. The grounding plate should be made of corrosion-resistant materials to ensure longevity and effectiveness. All grounding connections should be made using appropriate connectors and techniques to ensure a secure and reliable connection. The connection should be protected from corrosion and mechanical damage. After completing the grounding installation, test the continuity of the grounding system to ensure that all components are properly connected and that there is a low resistance path to ground. Use a multimeter to measure the resistance between the grounding electrode and various points around the pool. Regular inspections of the grounding system should be conducted to identify any signs of corrosion, damage, or loose connections. Any issues should be addressed promptly to maintain the effectiveness of the grounding system. Local codes and regulations may have specific requirements for grounding swimming pools, so it is important to consult with local authorities or a qualified electrician to ensure compliance. Proper grounding and bonding of a swimming pool are essential for protecting swimmers and pool users from electrical shock hazards. It is important to follow all applicable codes and regulations and to use qualified professionals for the installation and maintenance of the grounding system. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the grounding work. Electricity can be dangerous, and it is important to take all necessary precautions to avoid electrical shock. Remember, the goal is to create an equipotential plane around the pool so that if a fault occurs, the voltage difference between any 2 points within the pool area is minimized, reducing the risk of electric shock. Also ensure that all metal parts of the pool structure, including the pool walls, supports, ladders, and diving boards, are properly bonded together with a solid copper conductor of appropriate size, typically 8 AWG or larger. The bonding conductor should be connected to a common bonding grid or bus bar, which is then connected to the grounding electrode system. The grounding electrode system should consist of one or more grounding electrodes, such as grounding rods or ground plates, that are installed in the ground near the pool. The grounding electrodes should be made of corrosion-resistant materials, such as copper or copper-clad steel, and should be installed in accordance with local codes and regulations. All electrical equipment associated with the pool, such as pumps, filters, heaters, and lighting fixtures, should be properly grounded and bonded to the pool's grounding system. This includes connecting the equipment's grounding terminals to the common bonding grid or bus bar. Ground fault circuit interrupters should be installed on all electrical circuits that supply power to the pool and its associated equipment. GFCIs are designed to detect ground faults and quickly interrupt the circuit, preventing electrical shock hazards. GFCIs should be tested regularly to ensure that they are functioning properly. Also consider regular inspections of the pool's grounding and bonding system should be conducted to identify any signs of corrosion, damage, or loose connections. Any issues should be addressed promptly to maintain the effectiveness of the grounding system. Proper grounding and bonding of a swimming pool are essential for protecting swimmers and pool users from electrical shock hazards. It is important to follow all applicable codes and regulations and to use qualified professionals for the installation and maintenance of the grounding system.